Hey everyone, and welcome back to the channel. Today we are diving into a set of incredibly powerful SQL tools that will absolutely change the way you analyze data, and these tools are called window functions. We are going to use this simple table to understand window functions. Window functions let you perform calculations across a set of table rows that are related to the current rows. Think of it as being able to do aggregations and comparisons without collapsing your rows into a single summary row like a regular group by class does. Instead, the original rows are preserved and the result of the window function is added to each row. There are three types of window functions: aggregate, value, and ranking. Aggregate functions include functions like average, maximum, minimum, sum, count. Value functions include functions like row number, rank, dense rank, percent rank, and ranking functions include functions like lag, lead, first value, last value, etc. We will discuss and practice all these functions using this table in SQL queries. So let's start with the row number function, which is a type of value function. So we already have our select command, and we use the same select command in the window functions as well. However, we add a new column as a window function. So we have already selected all columns, then we will add another column, and here we will use the window function, which is row number, and then we will use over, and inside the bracket we will use the order by, and then we will identify the column which we will use as sequence, and here we will use the month column which contains dates as sequence. So we will use the word month, and then we will close the bracket, and then we will give this new column a name as window function. So we have just named it WF, and you can name it as anything. So if we click on the execute button, this will add a new column named WF, and here you can see that it has created a sequence of numbers from 1 to 48, and these sequences are following the sequence of dates in the month column. Now we can also use group by in this window function, and for that we will use the partition by instead of group by. So we can group these numbers by branches. So we will use partition by branch. And now let's execute this query. And as you can see, the data is now grouped by the branch column. So first, the east branch is displayed with numbers from 1 to 12. Then the north, and then south, and then the west. So these are the two important parts of the window function, which are order by and partition by. Ordered by is the column which you are using for the sequence, and the partition by is the column you are using to group the data by. So this is very simplified method of using the group by command while preserving each row as it is. Other functions are used in the same way. For example, let's replace the row number with rank. So now we have ranking instead of row numbers, but you will not feel the difference until you remove the partition by. And now you can see the ranking. So common dates are now ranked as 1, and then the next date is ranked as 5, which means there are 4 ones, and then there is 5th, then there are 4 fives, so this makes the next number 9. So this is ranking instead of row numbers. The rank function also follows the actual row number. So this is actually the 5th row, this is actually the 9th row, this is actually the 13th row. But if you want to ignore the actual row number, you can use the dense rank instead of simple rank. So now instead of 5, it is 2, instead of 9, this is 3, and instead of 13, this is 4. The %rank function will display your ranking in percentage, just as shown in this resulting column. So let's also use the partition by on branch column and see what difference does that make. So as you can see, the percent ranking is used on the individual branch in the branch column. So this starts from 0 and ends at 1, and the next group again starts with 0 and ends at 1, which is 100%. Again 0 and 100%. To divide the data by a specific percentile, we can use the NTILE function, and inside the bracket we can give the number, for example 4. So let's execute this function, and as you can see, each group is now divided into 4 parts, 1, 2, 3, and 4. And then the next group is also divided in the 4 parts, and so on. We can also change this number to anything else, for example 5. So each group is now divided into 5 groups. So if we remove the partition by, the entire table is now divided in 5 groups. So these were the value functions. Now let's go ahead and look at some ranking functions. So first ones are the lag function and the lead function. Lag function provides the previous value in relation to the current row, and the lead function provides the next value in relation to the current value. So let's try the lag function first, and then in the bracket we will provide the name of the column from where the value will be taken. So let's display the sales value from the previous row. So as you can see, the sales value from the previous row has been displayed, and in the uh, row where there is no previous row, the value is shown as null. Since we have used the partition by, therefore each group starts with the null value. Similarly, we can use the lead function to display the immediate next value in relation to the current row. So as you can see here, the next sales value is displayed in front of this current row. We can also use the offset value and the default value with both the lag and the lead functions. For example, let's use the lag function with 2 offset rows and 0 default value. 2 offset rows means that instead of next row, the value will be taken from after 2 rows, and the 0 means that if there is no value to be taken, the result will be displayed 0 instead of null value. So let's execute this query, and as you can see, these two values are 0, and this value is taken from here instead of here, which is the previous row. Since we provided 2 rows, so 1 and 2, so this value was used here, and since there was no value to be shown here, the value 0 was displayed. And instead of 0, we can also display data from another column as well. So we can display the current sales as well. So to do that, we need to enter the name of column here. So now, instead of 0 or null, current value is displayed. And in the same way, we can use the lead function as well. And as you can see here, in the last 2 rows, current value is displayed, and in the third last row, the value is taken from the very last row. And in comparison, this was the original lead function. We can also use the first and last value function here, which will display the first value and the last value in relation to the current row. And since we are using the partition by, the first value of the group is displayed here. As you can see, this is the first value. It is displayed in front of the entire east branch. And in case of north branch, the first value is this one, which is displayed in front of each group. And now let's look at some aggregate functions, which include average, maximum, minimum, sum, count, etc. These are the most important functions after the row number function, and these are used to calculate progressive totals and moving averages, etc. So let's use the average function first, and this is the result of our average function, and we are using the partition by branch. Therefore, the average function applies to each group. So at the start of the group, the first row sales and the average sales is same. In the next row, the average sales is the average of these two values. And in the last row, the average sales is the average of all these values. And when the next group starts, which is the north branch, again the sales and the average sales is same. But in the next row, the average sale is the average of these two values. So this is how average window function works. And if we remove the partition by, the average function will be applied to the entire table. And the other aggregate functions work in the exact same way. For example, this is the result of maximum function and the minimum function, the sum function, and the count function. So window functions are incredibly powerful for solving a wide range of analytical queries that would be much more complex or even impossible with standard SQL. They allow you to gain deeper insights into your data by performing calculations in context without losing the detail of individual rows. And with this, we end our today's tutorial. Thanks for watching. We hope you liked our tutorial, and don't forget to like, subscribe, and hit the bell icon for more insightful tutorials and updates.